All right, so we are in week number 8 of our summer course, and in this week we are discussing linear optimization. So a lot of time while making decisions, we have so many constraints attached to the decision. So we can have constraints like labor, the cost, time, resources. So we have to consider all those, and while considering those, we have to make a decision, and we have to either maximize our profit or minimize the cost. So in linear optimization, this this whole thing just talks about how to make best decision while either maximizing the cost or maximizing the profit or minimizing the cost. So this chapter is on linear optimization. So first I will give you brief overview of linear optimization, and then I will explain you with an example and how to find a solution for this kind of a problem. We will do a graphical method, and then I will also show you how Excel can do the same thing. So let's start by understanding the linear. So linear optimization so few things. First thing is probably we have to think about few terminology. So the terminology we are thinking is so the first thing we have to always consider in these kind of problems is the objective function. What is the objective? Either we call this objective function. So in each question, you have to identify the objective. What is the goal? Usually it can be maximizing the profit, or or minimizing the cost. Second thing, from each question, you should be able to see or identify few decision variables. Which is under the control of a manager. So we can control those, we can make decision on those. But there are some constraints which are out of the control. So I will also give examples for each of these. So there are constraints which are resources, but they're limited. We cannot exceed those constraints. For example, we have working hours, and in one day we can work 8 hours a day. So we cannot make 9 hours if there's a constraint. Or if there are human resource, we have 5 people working on a project, we cannot make 6. And then there are parameters. So which are known values. We plug in by we know those values based on our previous experience. So we use those to make our objective maximize. Our goal is to fulfill the objective function, either maximize the profit or minimize the cost. So let's take an example from the notes. So everything I'm talking here is already discussed in the notes. We will, sorry about that. Okay. Oops. I'm just trying to get the right marker. All right, so or I think I should start a new page. All right, so let's do an example. We have an example of, in the notes I have given an example of a jewelry store. So there is a jewelry store which wants to make bracelets and necklaces, but they are constrained with the cost of necklaces and the constraint of resources and assets they have. So they use gold and platinum, and they have to, so the question is like, I will actually share the question. So here, a jewelry store makes necklaces and bracelets from gold and platinum. Each necklace requires 3 ounces of gold and 2 ounces of platinum, whereas each bracelet requires 2 ounces of gold and 4 ounces of platinum. The demand for bracelets is no more than 4. So there's another constraint. So all of this, they're talking about constraints. And then a necklace earns 300 in profit, a bracelet earns 400 in profit. The store has 18 ounces of gold, so this is the total gold they have, and 20 ounces of platinum. The store wants to maximize the number of necklaces and the bracelets to make in order to maximize the profit. So the store wants to maximize their profit, so they have to decide how many bracelets they should make and how many necklaces they should make. They know that if they make $300 profit on a necklace and they make $400 profit on a necklace, so probably someone will say, okay, why don't we just make all the bracelets because they are making more profit? But the bracelets require 2 ounces of gold and 4 ounces of platinum. Okay, so it needs more platinum and not that much less gold. So they may have a higher cost on this. So we have to decide how we can balance these two things while fully using the total gold and platinum at hand and make number of bracelets and necklaces which will maximize their profit. So let's formulate this problem. So here they have given all the steps to formulate the problem. I will also go over each of them. Let me actually open a new, I'm trying to open, all right, so let's go back to the, all right, so all right. All right, so let's formulate the problem. So the first thing we should do in formulation, so every linear programming or linear optimization problem, we have to make a formulation. So the first thing in formulation, we should see what is our objective. So the first thing is to find the objective function or objective. Our objective is to maximize the profit. This is our objective. We have decision variables. There are two of them. The first one, let's call it X1, and we can call it anything, and is the number of necklaces to make. because this is the choice we have. And second one we call X2 is the number of bracelets to make. So our decision of the final profit will be based on these two things. And there are also some constraints. So we have constraints of gold and we have constraints of platinum. And also in the example, they say that there is a demand constraint for the bracelets. So bracelets cannot be more than 4. So let's put, so we also have constraints. All right, so so let's put one by one each and everything. The first thing, so the constraints has, there is a limit on gold. There is a limit on platinum. There is a limit on demand for bracelets. All right, so we have put everything we got from the question. Now we have to put it in a mathematical way. So the maximum profit maximization, let's say we call this profit maximization Z. So the profit is equals to Z. We call it, it depends on how many bracelets we make and how many necklaces we make. So how many necklaces we make and how many bracelets we make. So this is the quantity we are going to make. And then once we sell that, we know that a bracelet, a necklace is sold for $300. So, and a bracelet is sold for $400. So whatever, for example, if we make one bracelet and one necklace, the total profit would be $700. If we make no bracelets, no necklace, our total profit would be $400. If we make 10 of these and 0 of these, our profit would be $4,000. But we cannot make 10. We can only make, there's a limit on bracelets. So the limits, we have the limits and we can go over these limits. As for the gold, we know from the question that we have maximum of 18 ounces. So we can, whatever we can make should be equal to or less than equal to 18. So each necklace plus bracelet. So each necklace uses 3 ounces of gold. So this one is for gold. So the first line I'm just talking about refers to gold. And this, and we need almost 2 ounces of gold for a bracelet. So even if we make one, it should be less than equal to 18 ounces in total. We cannot go above 18. So that's why I put less than and equal to 18 ounces. So this is ounces. We cannot go above this. The second constraint is on platinum. From the question, we know that we have to divide the platinum, or we have to share the platinum in these two decisions, but it cannot go above 20 ounces because that's the total we have in the store. All right, so, and we know that each necklace needs 2 ounces of platinum and 4 ounces of platinum for 4 ounces is needed for 1 bracelet. So whatever we do, we cannot cross, we cannot go, this equation cannot be above 20. So whatever was in the question, we are putting it in mathematical equations. And the third limit is on demand for bracelets. Whatever we do, we should not make more than 4 bracelets. This is demand of bracelets. So we have, once we have put this in this form, this is like half question done. This is like half problem solved. If we have accurately put everything in mathematical forms, we are halfway done to solving our problem. So what we have to do now, we have to find a solution so that this Z is maximum while keeping these constraints checked. So we cannot go above, so we cannot make 5 and 5. So for example, if I put 5 here and 5 number of bracelets, I would be 15 into 2, or 5 and 10, it will be 25. We cannot go like that. We cannot make 5 5. We have to decrease it. We have to be under. So for example, if I make here, if I go 4 4 or 2 2 2 8 4, it will be less than, so I'm underutilizing my 20 ounces of platinum. I have to be perfect, so I use maximum of these so that my profit is maximum while not even going above other constraints. So I cannot cross other constraints. So one way to solve these kind of problems is to use a graphical method. So graphical method is the simplest, most efficient way to solve these problems. Not every LP problem we can solve with a graphical method, but these kind of problem can be solved by a graphical method. Sometimes there are so many constraints, or this function is not that simple. It can be more complex function. So once the maximization function is more complex, the graphical solution becomes much harder. To do the graphical solution, we have to make graph between X and Y and see that how we can do on different values. All right, so where did this thing go? Okay, so yeah, okay. So yeah, so let's make a graph between X1 and X2. So we are talking about graphical method for linear optimization. So we have to make a graph between X1 and X2. All right, my graph doesn't look very good, so I will just create again. Yeah, this graph looks much better. All right, so let's put, now something just happened to my, I think this is the best one. All right, so this is x2 and this is x1, sorry. And this is my graph. So we have values going for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like this. And then it's just one. I'm just making pretty rough graph, but we can get our solution pretty easily. All right, so this is our graph. So the values of x1 are increasing this way, values of x2 are increasing this way, just like a typical graph. All right, so to find solution for our graph, let's see our equations again. These are our three equations, and we should graph them on our graph. So the first equation we have is actually 3x1 plus 2x2. Since now we are talking about less than equal to, I will graph it for equal to 18. But with a less than inequality means the area below this line. So this is a line. This is an equation of a line, and the less than means the area below this. The second graph is, the second line is from our constraint is equal to this one, and the third line is equal to 4. So we have three equations. To graph them, it's pretty easy. We can actually graph them. For example, if we take the first equation, we can say, let's put x equals to 0. So I'm talking about, so this is equation 1, this is equation 2, this is equation 3. So from equation 1, we can say that let's put x1 equals to 0. x1 equals to 0 is mean this point. So when x1 is equals to 0, x2 becomes 9. All right, so pretty easy. We just put x1 equal to 0. So this whole thing becomes 0. x2, 2x2 equals to 18, which means x2 is equals to 9. So when x1 is 0, there's a dot here, and this point is 0, 9. So we have one solution. Same thing, we can use equation number, we can also use equation 1 and say x2 is equals to 0. So now we are saying, let's make equation 1, but put x2 equals 0. If we do that, we will get x1 equals to 6. So when x2 is equal to 0, we get this point, which is 6, 0. We can actually join these 2 points. All right, so this is our first equation. So this is coming from equation number 1. All right, let's take equation number 2 and do the same process. Equation number 2, we put x1 equals to 0. We will get x2 equals to 5. So x1 is 0. We get somewhere here. All right. And then same thing, if we put x2 here 0, so x2 is 0, then x1 becomes 10. So it goes here. So when x2 is 0, this is 10. So we can actually draw a line between these two. So this is our equation number 2. All right, so moving forward, we can see there's a third equation, which is x2 equals to 4. Whatever we do here with x1, the equation x2 remains same. So if x1 is 0, x2 is this point. If x1 becomes 1, x2 still keeps at 2. If x1 becomes 3, it still remains there. So we got this, and so what happened here is we draw these 3 lines. So this one is equation number 3. So my lines are a little bit up and down, but now the feasible area, we call this feasible area. So the best area is actually which is under all these conditions. So these 2 lines intersect here. So probably I should just be a little bit more, I think I should just make it one thing clear so you guys have better. So for example, oops, this is very bad. Okay, so let me draw my line again, and then, all right, so I'm just trying to draw perfect lines right now, which is like, I didn't make the perfect points, but I'm trying to make, so one line goes like this, other line goes like this, and the third line goes, for example, if this is our third equation. All right, so the feasible area, which is like the most possible solutions we have if they make this solution. All right, sorry. So either if we are here, if we are here, so all these corner points are actually a solution. So there is point A, B, this is C, and this one is D. All of them suggest a solution. What this means is that all of this area is actually feasible area. This is possible. It gives you some profit, and it's within the constraint. But only one of them is right now is giving us the maximum profit. So this feasible region shows all the possible, like even this point, you know, so this is actually 2. So this is nothing. So this point is 2. So making 2 and 1.5 of x1 will be possible, or making 2 of 2 necklaces and 2 bracelets would be a possible solution, but it's not the optimal solution. So everything within this, so I'm just putting the corners so that, but everything within these corners is actually a possible solution. But which one is the maximum solution? The best solution would be the one which is away from the center. The best solution would be the point which is far away from this starting point. So the point which is away, I can see from my graph that point number C is furthest away from doing nothing, the 0 point. So if point C is furthest, this point, actually this configuration of necklaces and bracelets will be giving me maximum profit. And what is this point number C? What is this? We can easily actually find all these points. This is pretty easy. This one, I know this is already, it's pretty easy. It's 2 and 0. So it's 0 and 2. So don't make any necklaces, only make bracelets. Okay, so X1 is necklaces, so make 0. So this is 1, but this is not optimal. This one we can also find, and this one C. How we can find C? Point number C is the point where equation 1 and equation 2 interacts with each other, which technically means that these two equations are equal, which means that we can take a subtraction. So we will find the point number C. So we have to find this point. So equation number 3x1 plus 2x2 equal to 18, and 2x2 plus 4x2 equals to 20. So the interaction point, the C point, the point where both of them combines, is when these two equations are equal. When these two equations are equal, we can actually find this by subtracting these two. While we are subtracting, sorry, this should be number 1. So this is 1. While subtracting, we can actually drop one of the variable, either x1 or x2. So what I can do, I can multiply this one, or I can multiply this one with 2, the first one. So keep this equation number 2 as is, and let's multiply equation number 1 by 2. So we will get 6x1 plus 4x2 and 36. Now we can take a subtraction of these two, this equation and this one. So once we multiply this thing by 2, we have to multiply with everything. And then if we take a subtraction of these two equations, this thing would be totally crossed out, and this would be minus 4x1 equals to minus 16. And this will yield x1 equals to 16 over 4, which is equals to 4. So x1 comes out to be 4. When x1 is 4, we can actually, if x1 is 4, we can put this 4 in any of these equations, any of the first two equations. So I'm putting x1 equals to 4 in the first one. So I will get 8 plus 4 x2 equals to 20. 4x to 20 minus 8. X2 is equals to 12 over 4, which means 3. So this point is 4 and 3. And this is the optimal solution. This is the best solution. These are the number of bracelets, necklaces and bracelets which we can make to get the maximum profit. So our answer here is 4 necklaces and 3 bracelets will give us maximum profit. Maximum profit. Okay, somebody say how much is the maximum profit? We can actually find that. It's pretty easy. So we have our first equation, if you guys remember, 300 x1 plus, what kind of plus is this? All right, 300 x1 plus, we had 400 of x2. Now we know x1 is equals to 4 and x2 equals to 3. So z is equals to 300 into 4 plus 400 multiplied by 3. This will give us 1200. The total profit is 2400. This is the maximum profit firm can make by changing, by selecting under these constraints, by making 4 bracelets, 4 necklaces, and 3 bracelets. So Z is our maximum profit. So this was the method to do this thing in through paper and pencil in a graphical way. If this would be a face-to-face class, I usually put few questions in the exam which are needed to be completed like this in a graphical method. But now I think it's I think I have put all the questions using Excel, but there are few questions which need some interpretation of graphical method. That's okay, yeah. All right, so now I will explain, do the same thing using Excel. I will put the same, I will create the same scenario in Excel and solve the problem using Excel. That's okay, Lisa. All right, so I'm turning on my Excel. All right, so to do this thing in Excel, we have to first put all of this information in Excel and then let Excel find the 2 points, the number 4 and number 3. Let Excel find it for us, but let's first see how we can make a solution in Excel. So if you see a problem like this one in exam or anywhere, please follow all these steps and do exactly like this. All right, so you cannot see my Excel. So let me just stop sharing this and then share Excel. All right, now you guys must be able to see my Excel screen. All right. So first thing, we have to put our problem name. So in this problem, we have to first put our decision variables, or any problem, follow these steps. So we have 2 decision variables, x1, which is for number of necklaces to produce. X2 is equal to number of bracelets to produce. Here we will put what's the value. So, well, X1 and X2 can change the values. So we have to put here, or maybe one more down, we can put value. So here, this column is for X1 and this is for X2. Remember that X1 is for necklaces and X2 is for bracelets. So for now, I'll put 0 and 0. All right. And then our profit maximization profit. So we have to make profit based on a product of X1 and X2. So if you think about it, I'm just putting all my equations, the equations I have made one by one in here. I put the 0, 0 value because I don't know right now what should be the value of x1 and what should be the value of x2. But I know if we take a product of these two, x1 will give me a profit of 300 and x2 will give me a profit of 400. So this is exactly equal to the z variable, or this is the profits we can get from each one of them. Now it comes to the constraints, and constraints are written as subject to. Even in the paper or in the graphical method, we write in the same way. So there's a constraint on the gold, there's a constraint on the platinum, there is a constraint on the bracelets demand. So from the document, if you remember, we can, because this whole column is for necklaces. So we cannot, so our necklaces use 3 ounces of gold and 2 ounces of platinum, and there's no restriction on demand of necklaces. But if you think about it, we have the bracelet need 2 ounces of gold, 4 ounces of platinum, and the bracelet is, if we make 1, we cannot go more than 4. So demand is not more than 4. So you have to think about the 3 equations we made. So I have actually lost those 3 equations, but if you go back, you will actually see these 3 equations in the paper. In the last, if you go back in the video, you can actually see these 3 things, and in this particular way. So the next thing we have to put is the total profit. So let's go in front of total profit would be based on some product. So this is a formula built in Excel, which is like product of these two, and then sum it. So I will use this one. All right. And then put a comma for array number 2, these two, close the brackets. Second, I can make them absolute by pressing F4 or putting $signs between each one of them. Technically, what I'm trying to do is I have to drag this box down, up or down, or change it would not, oh, I lost it. So let's do it again. Some product here, and I will do this, comma, and then this, and F4. All right. So I will actually make F4 on the whole thing. So right now it's 0. All right. So our total profit is currently 0, which is fine. Let's do the next step, because we didn't complete our constraints. If you remember, we were working on the constraints and then we went to put the profit formula. So same thing, we have to be in put our constraint limits. We will say, okay, these 2 things, and we will say, okay, so sorry. Some product, array 1 is this one, and array 2 is actually this one. All right, so this cannot go, this should be equal, less than equal to 18. So because if you remember our equation, we just put the values here. We never took a product. So now I'm saying product of this one with this value, x1, whatever comes up here when we solve it, and the number 2 into x2, whatever comes up here, 1, 2, because this will be changing in future. This cannot, so this whole thing cannot be more than 18. It can be equal to or less than 18. This is our constraint. So I'm putting my constraints here. The second constraint I'm putting is sum product, again, this thing, and this cannot go above this. This one less than equal to 20. All right, so the last one is again, sum product and this one. Even there is no value of x1, it means it's 0. So, but we have to put it. And this has to be less than equal to 4. So 1, if we make 1 x2, if you remember, the equation was like x2 equal less than equal to 4. So it's technically x2, which is this one, is less than equals to 4. So once we have established all of these things, we can actually go into Solver and run our analysis. So in data, there's a package called Solver. If you don't see this, if you don't see this particular solver in your Excel, make sure you turn it on. So this solver thing should be turned on from X and from here, from file. If you go to file, go to options, and within options, you have to go to add-ins, and then go to Excel add-ins. In Excel add-ins, you have to check mark this one, solver add-in. So make sure this is check marked. So once you have check marked, you will actually see this solver here. So to solve this problem, we can actually use Solver, and Solver is specially designed for solving linear optimization problems. So the first cell is asking us to set objective function. So the set objective, and this we have to point to a cell. We have to point to this cell. So we want this to be changed, or this should show our profit, maximum profit. And we want to make maximum profit by changing the values in the cell, these two cells, B8 and C8. And we can add the constraints. So now the time is to add constraints. So here, I'm saying cell this one, constraint is this one, add this. Cell this one, less than equal to 20, add. Another cell reference, add. So we have now three constraints based on these cells, and we have put a maximization problem here. I have put what is our objective should be, which has already a formula in there, which is saying product of these. So whatever this will entails, it should be changing these two values while making this one maximized, and within the constraints of these. So make sure you have check marked this, and this is not a non-linear problem. This is a linear problem, so you should put simplest linear method. And then just press solve. Once we press solve, we will see a solution of 2400. The values will be updated. And sorry, okay. And we will see this box. So here, those zeros are gone, and now we have 4 and 3. To keep the report, we can actually get a report for our solution. Press answers, and we will get an answer report, which shows the final value, which shows the which shows our best values for x1 and x2 while keeping the um, constraints into account. So this is our best solution, which is exactly the same as we got from the graphical method. So it's up to you guys if you guys like to use Excel to solving a problem or you guys use graphical method to solve a problem. The answer will be same. Excel is more convenient and it is more efficient because sometimes graphical solution becomes really hard to find. So that is it for today. And I thought this linear optimization is a very important topic and it is a hard topic. So that's why I thought I should give a deeper overview, but all these things are already available to you guys through notes. If you read the notes, you will be understand these things much better even than this video. So please read all the notes, go through the practice problems. It will be really handy for you in your quiz, homework, and in the final exam. All right, thank you so much. Mm.